So now we are doing exercise 4.3. This exercise mainly deals with the uses of determinant, a few of the uses of determinant. So already we have learned how to calculate the determinant of various matrices, right? 2 by 2 and 3 by 3. And then the properties we have learned, question based on properties we have done. Now a few uses. So let us begin. The first use of the determinant is in finding the area of a triangle. Now let us say a triangle is there with three vertices A, B, C, D, E, F, right? So to find the area of the triangle, the formula we use is half, like half into base into height, similarly half, and then the coordinates of the first vertex you have to write AB, then CD, and then EF, right? A, B, C, D, E, F in any order you may write it. And the third column, it must be 1, 1, 1 always. Okay, so when we solve this determinant and multiply it with half, you will get the area of the triangle. Now we'll see it by an example. 1, 0, 6, 0, 4, 3 are the vertices of the triangle. Okay, so I want to find the area of this triangle. First of all, I have written 1, 0, 6, 0, 4, 3. All the three vertices I have written. And then third column 1, 1, 1. And then multiply it with half. Now I put a modulus sign here. This is not determinant, it is modulus sign, but generally it is missing in various textbooks. Why? Because it doesn't seems good actually. It looks as if we have put another determinant here. Are you understanding me? In determinant already we are putting these bars. And if we want to show modulus again by putting these bars, it generally sometimes confuse students. So various books, they haven't put this modulus here. So what we can do actually, while calculating this determinant, instead of making brackets, you can make proper modulus sign, right? What is the use of that? You see, area of a triangle can't be negative. In fact, area of any two-dimensional figure can't be negative. So if this term comes negative, there should be something to make it positive, isn't it? So while calculating determinant, I'll be putting a modulus sign here. Don't be confused. It is not a determinant sign. And in the original formula, you can avoid using these bars. That is the modulus sign. So, okay, I've put half here according to the formula. Then this one. Then this term with changed sign. And then this one. Okay. Now, once you write this one here, hiding it with column and rows, you'll get 4 elements. Then 0 minus 3. Similarly, once you write this 0, by the way, there is no use of calculating this, but anyhow, once you write 0 here, hiding it with column and row, you'll get these 4 elements, 6, 1, 4, 1, and 6 on the 6 minus 4, it will be 2, 2 into 0 will be 0 later on, and this 1 here, and sign convention, I hope you haven't forgot the sign convention. This one I have written here, column row, height, 18 minus 0, that is 18. Now 18 minus 3 is 15. 15 by 2 is the answer. Just in case if it was negative, even then you can put a modulus sign and make it positive, right? So it's always better to use modulus instead of bracket while calculating the area of the triangle. Okay, second example, if we take, these are the vertices of the triangle. And again, how to put the values, 2, 7, 1, 1, 10, 8. In any order you can put them. And the third column, the determinant will be 1, 1, 1. And again, by sign convention, first of all, we'll write 2 without changing the sign. This second term with changing the sign, minus 7. And then this one without changing the sign. Right, so no change, change, no change. Then 2 you hide with column and row, you'll get 1 minus 8. That is minus 7. 7 you hide with column and row, you'll get 1, 1, 10, 1. Which when solved, it will give 1 minus 10, that is minus 9, and then hiding this one also we'll get 8 minus 10, that is minus 2. On calculating you'll get your final answer. Not a big deal at all. It is 47. Yes, 47 by 2. Okay, now this one, minus 2 minus 3, same question. I'm not repeating the question again and again. 3 2 and minus 1 minus 8, 1 1 1. Now we'll solve it. Minus 2, change the sign of minus 3, that is plus 3, then this one, and then if we hide this minus 2 with column and row, we'll get 2, 1 minus 8, 1, 2 plus 8, that is 10. If we hide this minus 3 from column and row, we'll get 3, 1, minus 1, 1. That will be 3 plus 1, 4. And if we hide this 1 from column and row, we'll get 3, 2, minus 1, minus 8. That is minus 24 and plus 2. That is minus 22. So if you see the calculation, you'll finally get minus 15. Right. And if you put modulus sign, already we are putting modulus sign to make it positive. The answer will be 15 square units. Right. So there is no confusion. Okay, next question. So show that these points are collinear. Yes, again the same concept we can use. If 3 points are in a straight line, then of course the triangle, we can't make a triangle from them, right? So even if we try to make a join these lines and try to make a triangle, we can't actually make a triangle. We'll make a straight line only, and hence the area of this triangle which we are not able to make will be 0, because there is no triangle, therefore its area will be 0. So this is the basic concept of collinearity. In class 10th also we have learned this, that if 3 points are collinear, we can't actually make a triangle out of them. So if triangle can't be made, so the area made by the triangle will be 0 as well, right? So simply what we need to do is the area of the triangle equal to 0. So the area of the triangle is half these vertices, okay, and third column will be 1, 1, 1. If we are able to see that the area is 0, then obviously these points are collinear. So one way is to simply solve it. Now we have already learned the properties. So what I am going to do is, one operation is done here, like a row 2 minus row 1 and row 3 minus row 1. This is one method. Another method that you can use is column 2. In column 2 you simply add column 1. In column 2 you add column 1. So what will happen? If you add column 1 in column 2, here you will get a plus b plus c, here you will get a plus b plus c, here you will get a plus b plus c, right? So from column 2 you can take a plus b plus c common. Okay, a plus b plus c you can take common from column 2, and outside already by 2 is there. So what you are getting finally inside the determinant? The first element of the first column are ABC. First element A, second B, C. Okay, from here we have taken common, so it will be 1, 1, 1, and this is also 1, 1, 1. So if two columns are identical, the determinant will be 0. So this whole thing is 0. 0 into anything is 0. So straightforward, your answer will be 0, and hence these 3 points are collinear, right? So one method is here also, you can see it, but try to see if an easy method is already there. Okay, let us proceed with question 3. So now what it is saying is, find value of k if area of triangle is 4, right? So simply we'll see this part. First of all, we'll put the coordinate of the vertices here, k0, 4, 0, 0, 2, and the third column as usual 1, 1, 1, and this area is equal to 4 according to the question, right? So on solving this, k 0 minus 2, then changing the sign of this second term, minus 0, and just wait a minute, okay, and hiding it by column and row, you'll get 4 minus 0, okay, and then third element, that is 1, hiding it with column and row, you'll get 8 minus 0, okay, and this whole thing is equal to 4, since the area is equal to 4. Now k into minus 2 is minus 2k, 0 into anything is 0, 1 into 8 is 8, inside modulus half, dividing by 2 we'll get minus k, this is minus k plus 4 modulus, that is equal to 4, right? So from here we need to find the value of k. Now once you remove modulus from one side, you will get plus minus sign at the other end, okay? So this is the basic technique that we have used in chapter 1 also. So by removing modulus from here, you will get plus minus sign here, okay? Now if we take the positive 4, and take 4 towards that side, right? If we take the positive 4 and take this 4 towards that side, so 4 minus 4, k will be 0. If we take this negative 4 and take this 4 towards that side, so minus k will be minus 4 minus 4, that is minus 8. On cancelling negative, you will get k is equal to 8. Understood? So this is how you will get two values of k, and just in case if you are not using modulus sign, then you will get only one value of k and the answer will be incomplete. You will get half marks only. Right? Now we'll come to second part. Again, the area is 4. Coordinates have been changed: -2 0, then 0 4, then 0 k, 1 1 1, determinant half, and the area is equal to 4 according to the question. Okay. Now we'll solve it. So what we can do, column wise we can solve, right? Because two zeros are there. So for these two zeros we need not calculate anything, only for -2 we'll expand it. So -2 will write, hide it with column and row, we'll get 4 minus k only, and dividing by 2 we'll get modulus of -4 minus k. -4 minus k means k minus 4 you will get inside modulus, and this whole thing is equal to 4. Again same process you will repeat. What same process? We'll remove modulus from the left side, and by removing modulus from the left side you will get plus minus symbol on the right side like this. So once if we use positive k positive 4, you will get k is equal to 8, and on using negative 4 you will get k is equal to 0. So again you have got two values of k. Okay, very easy. Next, so two uses we have seen: finding the area of the triangle, and second proving that 3 points are collinear. Now the third use we are seeing is find the equation of line joining 1 2 3 6. Equation of the line joining 1 2 3 6. Finding the equation. So already we know how to find the equation of a line by the knowledge of chapter 10 class 11, but using determinant also you can do the same. So what we'll do, we'll just take another point xy, and this point is taken in such an order or such a manner that these 3 points are collinear. These 3 points are collinear. So it is impossible to make a triangle out of collinear points, isn't it? And if it is not possible to make a triangle out of collinear points, it means the area will be 0 itself. Otherwise, how small the triangle may be, how thin the triangle may be, it will have some area. But if triangle is not at all possible, then we'll say its area is 0. Okay, so again by the same concept we'll say equation of the line joining can be made like this: xy1, this point, then second point 1 2 1, and then third point 3 6 1, right? So if a line is joining AB and CD, generally what we write, AB CD xy at the top, and then here in this column 1 1 1 multiplied by half is equal to 0, because area of the triangle is 0. But in some books you will not find this half. Why? Because we send this half towards 0, then only this determinant remains in the LHS, right? So you can avoid writing half also. Okay, so applying this formula, I think you got the idea. xy1, the arbitrary point that we have taken, then 1 2 1, and then 3 6 1. So as usual this column is made up of 1 only. Half is equal to 0. You can simply send half there, there is no use, and then you can solve this determinant x, changing the sign of y, minus y, 1 as it is, then hiding this x from column and row, you will get 2 minus 6, that is minus 4. Hiding this y from column and row, you will get 1 minus 6, that is minus 2, and hiding this 1 from column and row, you will get 6 minus 6, that is 0, and this is equal to 0. Okay, why? Because the points are collinear. So minus 4x and 2y, half can be sent towards 0. So minus 4x plus 2y is equal to 0. Hence 2y is equal to 4x, or y is equal to 2x. That is the equation of the line. Similarly, the second part is here. 3193 are the 2 points joining the line 3193. Third point we have taken xy, arbitrary point, which is on this line, and the area is 0 again, being collinear. You can send this half towards that side and then solve it. Just simply solve it. I am not solving it for you now. You can just see the calculation and you'll reach this equation, x minus 3y is equal to 0, right? So this one you can do by yourself. Let us proceed. Next, if the area of the triangle is 35 square units and the vertices are these, then the value of k is, so again same thing, half these points 2 minus 6, then 5 4, then k4, and the third column is 1 1 1, and this area you put equal to 35, right? A bit of an ugly 3, but okay, you will understand. 35. So solve it 2 as it is, change the sign of the 6 and then 1, hide this 2 by column and row, you'll get 4 minus 4, that will be 0, right? Then minus 6 we have written as 6, hide it with column and row, you'll get 5 minus k, done. This one you hide with column and row, you'll get 20 minus 4k. Now this will become 0 and 6 5 is 30, minus 6k plus 20 minus 4k, and then minus 6k minus 4k will be minus 10k, 30 plus 20 is 50, modulus, dividing by 2 it will become 25 minus 5k, which is equal to plus minus 35. Once you take plus 35, another time you take minus 35, you will get two answers. Answers will be k is equal to 12 and minus 2, okay. If we take plus 35, this 25 you can take towards RHS. 35 minus 25 will be plus 10, minus 5k is equal to plus 10, take minus 5 in the division, so 10 by minus 5 will be minus 2, okay. Similarly, if you take minus 35, take this 25 toward RHS, minus 35 minus 25 is minus 60, minus 60 divided by minus 5 is equal to 12, simple calculation, okay. So this is also done. So we have done this exercise. We'll see in the next video some interesting properties about determinants, right?